Hi students, it's Mr. Rink here. It's day 77. The title, Applying Quadratic Functions. We're going to be learning about that today. And our objective for today is you will be able to apply the fundamental theorem and describe relationship between two quantities using quadratic functions. So, the fundamental theorem you already know about. Fundamental theorem, it's like me saying how many times does the graph touch the x-axis, right? Touches here and here. So that's just math, but we're going to talk about stories today, applying it, what we're learning to stories, okay? So we're going to know about that, and then we're also going to talk about the relationship between the x and y axis in quadratic functions. So we've learned a lot about math, and now we're going to talk about stories that apply to math. So if I could just please have the teacher pause here, and when the teacher pauses, I need students to write down the objective and also the title here. So let's pause the video here, please. Alright, so students should have written this down. Let's go to the next slide. Students, you need to now write down the steps. You can start writing them down right now as I tell them. So the steps are you need to read the story and think about what's going on in the story. So sometimes you might have to reread it. Sometimes it's hard to know what's going on in the story, but read the story, understand what's going on. Then you need to identify what the problem is asking for. Usually it's saying find this specific answer, or so you have to think about it in terms of the story. The third thing is to solve, use technology like a graphing calculator. So we could do this by hand, which you should know how to do, but today we're going to use technology to make it a little easier on you. Okay, so and our graphing calculator is Desmos, and then answer the question in the story. So these problems take a little bit longer, so I'm only going to show one, but right now I need the teacher to please pause the video here. Students who are writing down all the steps on this screen, please. If we could please pause the video right now. Alright, so the video was paused. You kids should have all this written down. Here we go. So, story time. Alright, here we go. So, here's number one. An arrow shot into the air is modeled by the equation y equals negative 29 over 9t squared plus 58 over 3t, where y is the height in feet of the arrow above the ground t seconds after it is released. Which is the maximum height the arrow reaches? So when I read the story, I'm thinking about there's someone who has an arrow, right, and they're shooting it in the air, which is kind of dangerous, by the way. But let's pretend that someone has an arrow, right? Let's see if I could draw. Hey, that looks pretty good, right? Well, this guy's hand should be all the way out here, and then there's a really long arm. There's an arrow, right? I think that looks pretty good. I think that's alright. Anyways, shoots it in the air, right? Probably shoots it straight up, and it's going to land someplace. Okay? So it kind of looks like a quadratic equation, right? So I'm imagining this person shooting it into the air. And it's giving me some information here. It's giving me a y, and it's giving me another variable t. Sometimes these other variables can be confusing, so I like changing or assuming that the t is like an x. So, but it gives us an idea of what y is. Y is the height of the arrow in feet, so kind of getting some ideas. So I know there's going to be a y-axis. So I can pretend there's like a y-axis here, right? And there's going to be an x-axis, right? And you can see we're kind of seeing what are my intercepts, right? And t seconds is what's happening. So as time is passing by, the arrow is going up and then back down, right? So we could see that this kind of looks like a quadratic graph, right? What's the question asking here, though? It's asking me what is the maximum height the arrow reaches. So What is the maximum height? Alright, so I'm not really asking how far does the graph go, or like how far did the arrow go. Are we asking how far it is? No, we want to know how high did it go, right? So I want to know what is this height, the highest point it went to, which is way up here, right? And we all know this is the top of the quadratic graph, which is called a what? Starts with a V. A vertex, that's right. It's a vertex. That's correct. Good job. Alright, so that's your vertex. So how high is the vertex? So we know our vertex is going to have an x value and a y value. So remember, our y is represented by, I'm going to circle it up here, y is the height, so we want to make sure we get that. So we want to focus on the y. Alright, so now we know the story. We could all imagine there's someone shooting an arrow in the air. It has this equation, kind of scary because it looks like fractions. It's not really that scary once we use a graphing calculator. I know that it's not asking me how far it went. It's asking me, if you look right here, what is the maximum height, right? So that tells me, let's look at our vertex, right? So now that I know the story and what I'm looking for, I'm going to write down this equation on the side. So let's all write this down, the equation up here. Y equals negative 29 over 9 t squared plus 58 over 3t. I'll give you 10 seconds to write this down. Okay, cool. So you should have written that down. Now I'm going to go back to my graphing calculator here. So give me a moment. I'll go there. Okay, so I went into Desmos and I plugged it in and I graphed it, right? And you could see it kind of looks like our little example, right? I'm kind of zoomed in too far, so I'm going to zoom out. And I could see what's happening here, right? And if I kind of zoom in some more, maybe I could get a wider idea. So it looks like we have a graph here. Give me a moment. I'm going to just adjust this a little bit on my end. So my x-axis, I don't really care about negative time. Maybe I'll just do like -2 up to +10, right? And the y-axis, maybe I'll go like just to zoom out or zoom in a little bit so it looks a little nicer. So I can see the x and the y-axis. Cool, right? And we can see what's happening here, right? I'm looking for, I know that there's a answer here and here, right? But that's not what the problem is asking. It's asking how high did it go. So I want to see what my vertex is, right? So as I look at this, I know that someone is shooting an arrow down here, right? So I can imagine the arrow going up in this direction, right? And going all the way up into, as time is passing, it gets up to a certain height, and then it comes back down, right? And it takes, from the time it starts to here, if I look at the x-axis, it starts from 0 seconds and goes to 6 seconds. But remember, the question's not asking how much time or how far did it go. It's asking us how high did it go, right? So when I look at that, I want to see how high it went on the y-axis. And I could do that by looking at the vertex. And we notice after 3 seconds, if I look up after 3 seconds, we get to a vertex. And we say, hey, 3 seconds, it's how high? 29, right? 29 is the number I'm looking for. That means it's 29 what? Well, I have to go back to my problem and remember, I don't know if it's feet or meters or whatever or yards. So I'm going to go back to my problem now. So as I go back there, sorry about that. Going back to my problem, I noticed it was after 3 seconds. My vertex is at 329, right? So if it's at 329, we know that it's going to be 329. We have 29 feet right here, right? So the question again is, what is the maximum height the arrow reaches? We would say the maximum height the arrow reaches is 29 feet, okay? Right? Now, if the question was different, like how long is it in the air, then we would see how far it is from when it started to when it ended on Desmos, but that wasn't the question. Anyways, I'm only showing you one example today. You don't need to write this down. I'm assigning you AMs for this. There's only 6 problems, so use Desmos to help you out. Use today to catch up on some of your work in here. Some of you are pretty far behind, some of you are on task, so please do that. And that's it. So that was the goal of the lesson. We are using technology to answer questions which have real life scenarios. Alright? Anyways, thank you so much. That concludes the lesson.